Hello everyone. Let us continue with homogeneous functions. Now the expansion part generated by the Govt function is linear. The first order condition of optimization requires that R1 by R2, that means this is the price ratio. R1 is the price of input 1 and R2 price of input 2. So our inputs are labor and capital is equal to the ratio of marginal physical products. So F1 is the marginal physical product of labor and F2 is the marginal physical product of capital. Now if you cross multiply, it becomes the marginal value product. MVP1 is equal to MVP2. So F1 by F2 means first derivative with respect to labor and first derivative with respect to capital. F1 by F2 is equal to BC by 1 minus BL. So common is alpha L to the power beta C to the power 1 minus beta. So in the numerator and denominator it will be cancelled. So BC, beta C by 1 minus beta L is equal to R1 by R2. So input price ratio and F1 by F2, this is the marginal rate of technical substitutions. The expansion part is given by the implicit functions 1 minus beta into R1L, so is equal to beta R1C or 1 minus beta R1L minus beta R1C is equal to 0. So this shows that it is a straight line emanating from the origin in the isequant plane. A degree of homogeneity of Govt function is 1. So it is always assumed that in Govt function the degree of homogeneity is 1. It is also called linear homogeneous functions. So since power is 1 of the variables, it is called the linear homogeneous functions. In general, it is homogeneous of degree equal to its sum of power. So when we will sum the powers of the variables, then it is the degree of homogeneity. So suppose sum say beta I, that means all powers. If we add together, then the value becomes the degree of homogeneity. If the sum is 1, it is the special case of being linearly homogeneous. So it is said that it is linearly homogeneous if the sum is 1. And sum 1 also indicates the constant returns to scale and negatively so of isequants. Now, there are few properties of homogeneous functions. Let U is a homogeneous function of degree h. U is a function of xy. So, let us multiply the variables by t factor. That means t to the power h function xy. It says that U is a homogeneous function of degree h. Let t is equal to 1 by x. So generally t we take 2, 3, 4, whatever may be, but let us take t is equal to 1 by x, a reciprocal of x. We can take reciprocal of x. Not only the 2, 3, 4, 5, no. We can also take the reciprocal of x or reciprocal of y. Okay. Then this is equal to 1 into 1 by x, because if we multiply by 1 by x, it will be 1, and this will be y by x. So this is a new function, and this is a y by x, phi y by x. So variable is a ratio. Again, replacing t by 1 by x, t to the power h is 1 by x to the power h is the function of xy from 1 and 2. So if we take the function from 1 and 2, fxy is equal to x to the power h phi y by x. So this is the equation 3. Now equation 3 is possible if the function is a homogeneous of function degree h. Start the remaining part of it. So one example, say function xy is equal to ax square y plus bxy square. So this is the function, it is given, and h is equal to 3. So degree of homogeneity is given. So then x square into a y by x plus b y square by x is equal to x cube phi y by x. So from earlier theory you can write that if h is the homogeneity is 3, then x square, that is x cube into a by yx. That means if we multiply by x3, it will be ax square y, and this will be bxy square. So it is the function again. So x square phi y by x we can write. Then property 2, in a homogeneous function of degree h, kh partial derivative of the function is a homogeneous function of degree h minus k. Let us test it. Now it is related with the partial derivatives. So the total derivative and partial derivative, it is said that in partial derivative the degree will be less by 1, h minus k. So if first derivative was suppose 4 or 3, then next derivative will be 3 minus 1 or 4 minus 1, like that. Okay. Now let the function is x square y square plus xy cube. What is the first derivative of this? 2xy square plus y cube. Now homogeneity of this function x square y square plus xy cube is equal to what will be the homogeneity? Tx square into ty square plus tx into ty whole cube. Now t square, this means t square x square and t square y square plus tx into t cube y cube. So if we simplify, it will be t to the power 4 x square y square and t to the power 4 x y cube. So t to the power 4 is common, it will be x square y square plus x y cube, the original one. So degree of homogeneity is 4 in this case. So degree of homogeneity is 4. Now fx, first derivative with respect to x, is 2x y square plus y cube. Now let us test the homogeneity of this. So if we raise the variables by t times, okay, 2tx into ty square plus ty whole cube is equal to 2tx t square y square plus t cube y cube. So we can take t cube common. Here it will be t cube x y square. So t cube, in this case t cube 2x y square plus here t cube y cube. So if we take t cube common, it is 2x y square plus y cube. So we are coming to the origin functions, first derivative. So that means degree of homogeneity is 3. So earlier we got degree of homogeneity is 4 for the main function. Then in the partial derivative, that means with respect to fx, or we can find out with respect to fy. So we will find, we have found here that partial derivative is less than 1, less 1. Sorry, if it is 4, it is 3. Now it is said that if we find out the fxx, that means our derivative fx is this, ultimately fx is this, sorry, fx is this. Now if we find out fxx and test the homogeneity, it is said that the homogeneity will be less 1 of this. That means the degree of homogeneity will be 2. So this I have kept it for homework. Okay, homework. So hints is that function xy is equal to x to the power h pi y by x. Find fx, then fxy. Find fx from this, then find out fxx. So we'll have to start from here. Use product and quotient rule in derivations.